All right, everybody. Good morning. Here we are learning something new called the distributive property. What you're going to do first in class today is an activity to review combining like terms. It's a math libs. It's supposed to be fun. I hope it's fun for you. Miss Soon understands the activity and will lead you through it. It's important that you get through all 10 problems, that you do your best, and that you work to combine like terms. Please note that number 9 and 10 are tricky, number 10 in particular. Importantly, you'll need to know how to add and subtract positive and negative numbers. That's really a key. So, where are we going after this? You are heading in Canvas to something called the distributive property, and this is our Algebra Stations number 2. You'll see here what you have to do. There's the typical stations A, B, C, D. I really only expect you to get through A and B and possibly C once you get through the combining like terms math lib. So if you click here on the algebra tiles, what it will take you to is this screen here. And what we're going to do now is we're going to model multiplication. And by modeling multiplication, what it says here, it says use the tiles to model the problem 2 times 2. It's fine to write numbers or terms next to each other, one on the outside of parentheses and the other inside parentheses, and that will mean multiplication. So this says 2 times 2. I'm going to take 2 and I'm going to put it on the left side of this matrix, and I'm going to take another 2 and I'm going to put it on the right side of this matrix. So you'll see what happened down here. I have a 2 in parentheses, that's that first 2 here, and I have another 2 in parentheses, that's the second 2 here. 2 times 2. You'll notice that it created a rectangle here, and I have to be able to fill that rectangle with values that make sense here. So what am I going to put here? Well, I have a 1 times a 1. Well, 1 times 1 is, no shocker, 1. Here I've got a 1 times another 1, so that's going to be another 1. You can see I've got a counter coming up as well. Over here I got this 1 times 1. That's another 1. And this 1 times 1. Which, to no one's surprise, 2 times 2 is 4. Right? So what we're going to do is do a new one, a slightly harder one. And what we're going to do is we're going to represent negative 3 times 3. So on one side of the matrix I'm going to put negative 3. 1, 2, 3 reds, right? Red is representing negative. And I have 1, 2, 3. Now everybody remembers what negative 3 times 3 is, because a negative times a positive is going to give us a what? Well, here I've got negative 1 times 1. Negative 1 times 1 is going to give me, ta-da, a negative 1. Oops. I'm going to have lots of negative 1s in here, because negative 1 times 1 is always going to be negative 1. And you can predict what the answer is going to be. So this is a model of multiplication. I actually don't want you to do this, but I'm showing it to you because this is how the model works. Whatever is here, you multiply it times whatever is here. What we're going to do is go, instead of multiplying terms by each other, we're going to do something called distribute, because we're going to learn about the distributive property. So what this wants me to do is 5 times negative 2x minus 2. So the first thing I'm going to do is set up my 5 on one side of the matrix. 1, 2, 3, 4, 5. Then it says to do negative 2x minus 2. So there's one negative x. There's another negative x. Negative x plus negative x is negative 2x. Then it says minus 2. Well, here's what we're going to do. I've got to fill in this big rectangle. And here I've got 1 times negative x. Well, 1 times negative x is negative x. Same all around. Like so. That's not very good in terms of lining up. 1 times negative x, 1 times negative x, 1 times negative x. You'll have to play with this to get used to the way it feels. And then here I've got 1 times negative 1. And just like before, 1 times negative 1 is going to be negative 1. Oops. you'll notice that when I'm multiplying a red times a non-red, I'm always going to get a red. I bet that you can figure out when I multiply a color, like yellow, green, or blue, times another color, yellow, green, or blue, that I'm going to get that same color, yellow, green, or blue. Okay, I'm finally done. 5 times negative 2x minus 2 equals negative 10x minus 10. This is what I'm going to want you to write in your binder as a record of what you've done today. I want you to record at least 5 of them. Why is this so? Well, we just modeled this here to prove that it's true. But if we take 5 and then we multiply it times negative 2x, 5 times negative 2x is 5 times negative 2 times x. Well, 5 times negative 2 is negative 10, so we have negative 10 times x. And then we distribute this 5, and we take 5 and we multiply it times this negative 2. And 5 times negative 2 is negative 10. And so those are all of our negative 10s right there. And that is the distributive property. Okay, so again, what I want you to do in this station is I want you to make sure that you record 5 examples of the distributive property. You do not have to draw the picture. You just have to write the expression and then what we call the expanded form expression. Okay? That's it for that station. Station 2 is the Solve Me mobiles. You've seen this before, and it's very fun. It's just that game where you can play and you have to determine what the values are of each of the shapes. I'm particularly stuck on this one. See if you can figure it out. Good luck. I love this one. Anyway, that's those. Have fun with those. And then here on Math Playground, we're going to create a digital model of one-step equations. And in fact, you can do two-step equations if you want. So let's look at what this means. Here in Math Playground, we've got some models. And you should know that the sound, you're not going to hear it, but it's terrible. I hate it. So what we're going to see is we're going to model one-step equations. Building off Solve Me and understanding the idea of balance, this says x plus 3 equals negative 11. Notice how we're now doing equations. This is not expressions, this is equations. And so equations do have solutions, unlike expressions which can just be simplified. So here we want to know what number, when we add 3 to it, will be negative 11. In order to do that, we're going to use the idea of the balance. So what we're going to do is model this equation. On one side, we're going to put an x. And then it wants us to put plus 3. So I'm going to click the left arrow and add 3. But then it equals over here negative 11. So I'm going to go down to my negative ones, and I'm going to add negative 11. There we go. Once I'm done and I did it correctly, it'll click a check. So on one side I have x plus 3. On the other side I have negative 11. See how doing the pan balance challenge really helped us the other day. Now it asks me to isolate the x tiles. To isolate means I want to have just an x over there. Well, that means I have to get rid of these. If you remember, how do I get rid of positive 1? Well, I add it to negative 1. But we're going to learn that what we do to one side, we have to do to the other. And this is a really great model of this. So again, to get rid of the plus 1, I'm going to do minus 1. And it makes this really horrible noise if you can hear it, but you probably can't hear it on my computer. You'll hear it on your own. And then this is going to get rid of that next one. Again, a terrible noise. And this will get rid of the final one. And there we go. When we're done, we're pretty good here. We have a balanced scale. We have just x by itself on one side, and then we have negative 14 on the other side. And that should make sense, because if we plugged in negative 14 here, that would make the equation work. Negative 14 plus 3 does equal negative 11. So I click my check, and it asks me to type in what my answer is. And if I get it right, it will give me a huge check mark. So that's modeling one-step equations. You can always model two-step equations, which is a little bit different. This asks me to model 2 times x plus negative 8 equals negative 4. So we'll try that. I'm going to get 2 times x plus negative 8 equals negative 4. So now I have to get rid of all these negative ones. How am I going to get rid of the negative ones? With positive ones. You'll notice I have nothing on the balance at this side. This is okay. I can keep going anyway, and what's going to happen is it's going to start adding some ones to that side. I really like this model because it splits up the x's like that, which I think is pretty cool. So here we have now 2x equals 4. Well, if 2x equals 4, I'm going to divide the 2x in half. I'm going to divide the 2x by 2. That means I'm also going to divide the 4 in half, or I'm going to divide the 4 by 2. So it does that for you. And now it'll show me that 1x is worth 2. So x equals 2. And let's think if that makes sense. If I plug in 2 here, that means 2 times 2 is 4. And 4 plus negative 8 does in fact equal negative 4. So I'm going to be sure that that's true. Awesome. Good job, me. So in your binders, all you have to do here is record the equation and then record the solution, or x equals whatever value x equals. You should do this for about 5 times. All right, that's it. I've been talking for a long time, and now you know what you need to do after you finish the Combining Like Terms Math Libs. Good luck.